So for this question, we're given that y is equal to tan inverse of 2x. So we can treat this as tan inverse of something, like I always love to do. And we're basically asked to differentiate. We have to find the derivative. So how do we find the derivative of an inverse function? The first thing that we do is that we're going to get rid of this tan inverse by basically doing tan of both sides. Alright, and now we're going to differentiate both of the sides with respect to x. So trying to differentiate this with respect to x. Realize this is y, just hold on for that. So we're trying to differentiate a function in terms of y with respect to x, if that make any form of sense. So we're going to have sec squared y dy dx is equal to 2. Because this is in terms of x now, we can just differentiate it like normal and say, okay, that is equal to 2. But they're asking us to differentiate a tan function. They ask us to differentiate a function in terms of a function that is written in terms of y, and we're asked to differentiate it with respect to x. So that is the reason why we have it looking like that. If you want to go over the rules of doing that, you can basically try to get to this dy dx on one side by itself. So we're going to have 2 over sec. Guys, it's basically one form for each of them. So you might not get a tan, you might get a sine inverse, you might get a cos inverse, but it is the same principle that's going to work, right? You're going to do the inverse of this. Inverse of tan inverse is tan, so you're going to do the inverse for both sides and, you know, work from there. And yeah, all right. So we're given that dy dx is equal to 2 over sec squared y. And if we remember our identities from L6, which is important to know your identities, we know that sec, I shouldn't write it here because I'm going to need space. We should know that, let me just hitch it up here if everybody can see. We should know that sec squared y is equal to 1 plus tan squared y. Or if you're given it as sec squared y minus tan squared y is equal to 1, however you know it, but you need to know these identities, because they're just going to be embedded into a question and you're just going to work the question. Don't know the identity, then have to stop. So know your identities. So that is dy over dx is equal to 2 over 1 plus tan. I apologize for my special writing, but that's the reason I talk so much, so that you can understand what I'm saying, you know. But if we remember that what we initially put this as, we had tan y is equal to 2x, right? So we need to take this tan y is equal to 2x and put it in down the bottom. So that would be 2 over 1 plus tan y is equal to 2x, but we're not working with tan y, we're working with tan squared y. So therefore the way how we're going to have that is that we basically have tan y all squared. So then that is 2 over 1 plus 2x all squared, and the final answer is 2 over 1 plus 4x squared. So as I was saying, the important things that you need to know when solving this problem is, 1, your identities, right? So there are, I think, 9 of these are, so they're in different forms. So please know your identities from unit 1. Don't throw away a unit 1 book, go back to a unit 1 book and know your identities, because they're very important. And from then it's just algebra for each of them, because this could be sine, and you need to know the identity that involves the cos or the sine. So we're going to have, we had y is equal to tan inverse of x squared, then we did tan of both sides, and the whole works. So that's what happened. Okay, so for this question, we're given a complex number. Z is equal to root 3 plus, and we're basically asked to express it in a form, and this form is called polar form, right? So when we're expressing something in polar form, we need 2 things. We need the angle, and we need the number that's going to be outside of the bracket. And be outside of the bracket is called r. So basically, for this form, we have something like z is equal to a plus bi, and we're asked to put in the form z is equal to r cos theta plus I sine theta. So we realize this kind of look like over here. So A would be the root 3 and then the BI. So, okay. Now the first thing that we need to find is R. And how do we find R? So R is equal to the modulus of Z. So we need the modulus of this, right? So now we will have the square root of this squared. So root 3 squared is equal to 3. So it's going to have 3. If you want to have root 3 squared and complicate your life. And then this would be 1 squared, which is equal to 1. And that is equal to root 4, which is equal to 2. So the first thing that you realize is, okay, alright, me know so the number up on the outside are 2. Right? So the only two options that it can be is A and B. So now we're saying, okay, what's next? What else do I need to find? The next thing that we need to find is the argument, and the argument is theta. So now theta is equal to the tan inverse of B over A. So what is B? This looks like something where it's supposed to be a minus 1. I'm sorry. Is equal to, so B would be 1, and it's basically 1i, but because it's just 1, we don't write it. So we're going to find a tan inverse of this. But they don't have it in degree form. They have it in the form of radians. So a quick conversion, or if you wanted to just find it in radians to begin with, but not everyone knows how to do that. So you're just going to multiply it by pi and divide by 180. And then that now is going to be 6. So that's equal to pi over 6. Now, there's some little things that always baffle me sometimes, and I don't really like to remember formulas, so I just find like a easy way to know it. So you're given 30 and you have to convert this to radians. I know you have pi over 180. I know you have 180 over pi. But my little way of doing this is saying, okay, whatever I'm moving from degrees must be in the denominator to cancel. So we're moving from 30 degrees, so therefore 180 must be in the denominator. If this was radians, then the radians will be in the denominator. So that's equal to, so one of the two things, so now the answer is equal to B.